Welcome to 10.6 Ohm's Law. What's Ohm's Law? Well, first of all, we need to know who's Ohm. And we've got George Ohm. I think that's how they used to spell George, or George. Ohm, 1789 to 1854. That's what he looked like. And his law tells us about the relationship between current and applied potential difference in a conductor. So it relates current to the voltage. Many components obey Ohm's law because it is a law, but they don't have to, so others do not. But if they do obey Ohm's law, it's a case that it's a law. And it's written as V equals IR, which is on your information sheet, where V is voltage, I is current in amps, and R is a new term for us, is the resistance, and it's measured in ohms, which is also given by this symbol here. So this pretty much explains Ohm's law. Now this would be a circuit that we could use to actually examine Ohm's law, and which people do, and if we get time we might well do a prac using this. And so you have a power supply, you have what's called a variable resistor, so you can change the parameters in the circuit. You have an ammeter for measuring the current. You have a length of resistance wire, which is just wire, and a voltmeter that measures the potential difference across this wire. This would actually be better drawn like this. Let's see, like that, where we don't have that bit. Okay, that's just so this voltmeter is just measuring the voltage across this coil of wire, and then the rest of the circuit. And by using the variable resistor we can actually change the current in the circuit, and we can record the variation in voltage across this wire. And this would be some typical results. So you start with 0, 0, nothing in the circuit, and then you can change the voltage, and if you plot the current versus the voltage you get a straight line like this. Okay, so you can say that the current is proportional to the voltage. It's a straight line. This would be a dashed line if we used a longer piece of wire. So if we had more and more coils in here, because basically a wire is a resistor, and we'd get a different line. Now the slope of this happens to be the resistance. So if we were to work out the rise over run, that would be the resistance. Okay, now so if we can get rid of that, all that, and we can move on. Okay, and so not all components obey that law, so they don't represent a straight line on a current versus voltage graph. So this would be an Ohm's law object, but something like a filament globe, it changes its resistance as it heats up. Okay, now part of Ohm's law was that it shows consistent variation, and so filament lights, they get less and less resistant as they heat up. They start off obeying Ohm's law, but then rapidly depart. And there's other things as well, thermistors, which measure temperature, and so if you have a temperature gauge on anything like your phone or anything like that, it's usually coupled with a thermistor, which is a tiny little piece of electronic equipment, miniaturized inside your equipment. And semiconductor devices like diodes also don't obey it, and things called light dependent resistors, but we don't really need to know that. All you need to know is if you plot it on an IV graph and it's not a straight line, it doesn't obey Ohm's law. How's that sound? Okay, now that leads us on to how we actually measure resistance. Remember in the last video I said, well, we don't have a meter for reading resistance, we just calculate it from the voltage and the current, and this is a setup in which we could measure the resistance. So here's our circuit, there's our ammeter measuring the current, there's our resistor that we're interested in, we put the voltmeter around it, we get these numbers, 0.3 amps and 3.3 volts, and we put it into this formula, which has been rearranged. So V equals IR equals R equals V on I, and we get 11 ohms as the resistance. Okay, and that's all we need to do for that. So you're going to have a handout on Ohm's law calculations, and these will be your answers. Not many questions, but have a go at them and see how you go, and ask any questions if you have any. Alright, next video will be on direct and alternating current.